In this lecture, we use the Moivre's theorem to prove that minus 1 plus I root 3 upon 2 whole to the power n plus minus 1 minus I root 3 upon 2 whole to the power n has the value minus 1 if n equal to 3k plus minus 1, and its value is 2 if n equal to 3k, where k is an integer. So we have to find the value of minus 1 plus I root 3 upon 2 whole to the power n plus minus 1 minus I root 3 upon 2 whole to the power n. Now consider minus 1 plus I root 3 upon 2. It can be written as minus 1 upon 2 plus I root 3 upon 2. And now this can be converted into the form of polar form. So how to convert into polar form? So just let us see here what is the modulus of R, or modulus of x plus iy, modulus of x plus iy. So this is nothing but root over x square plus y square. So here, what is x square? X is equals to minus 1 by 2 whole square plus root 3 upon 2 whole square. So this gives us 1 upon 4 plus 3 upon 4, which is equal to root over 4 by 4 means 1. So the value of r equal to 1. The value of r equal to 1. Similarly, if you want to find what is the value of theta, so theta can be written as, since it is in the which quadrant? X is negative and y is positive. So if we draw this complex number, this will be in the second quadrant. So in second quadrant, theta is equal to pi minus tan inverse of mod of y by x. So this can be written as, what is the value of pi? Pi is pi, tan inverse of, we have taken the modulus sign, so root 3 by 2 upon 1 by 2. So this 2 and 2 will cancel. Pi minus tan inverse of root 3, which is nothing but pi minus pi by 3. So this is 3 pi minus pi means 2 pi by 3. So here the value of r, so if you want to convert this into polar form, r cos theta plus I sin theta. Here r equal to 1 and theta equal to 2 pi by 3. So if we substitute this value over here, r equal to 1 over here and theta equal to 2 pi by 3. So now we have to first convert this expression into the polar form. Therefore, minus 1 plus I root 3 upon 2 whole to the power n, it will be equal to cos 2 pi by 3 plus I sin 2 pi by 3 whole to the power n. And if we apply the de Moivre's theorem, this n is multiplied with the theta. So n times of 2 pi by 3, and similarly here also 2n pi upon 3. So this is the value of minus 1 plus I root 3 upon 2 whole to the power n. Similarly, we can also find out what is the value of minus 1 minus I root 3 upon 2 whole to the power n. It is only the plus sign will be converted to minus sign. Rest of the things will be similar. So let us try to add these two things, what we are getting. So adding 1 and 2, we get z equal to minus 1 plus I root 3 to the power upon 2 to the power n plus minus 1 minus I root 3 upon 2 to the power n. Its value is cos 2n pi upon 3 plus I sin 2n pi by 3, and its value is only cos 2n pi minus I sin n pi by 2. So there is only difference between the minus sign. So this is one is plus and another is minus. So we have its value is 2 times of cos 2n pi upon 3, and we know that what is the value of n. So depending upon n, we are able to get the different values of this value of z. So let us consider case number 1. If n equal to 3k plus minus 1, then what will happen? So z equal to, this is 2 cos, let us substitute 2 cos 2n pi upon 3. So let us substitute n equal to 3k plus minus 1. So 2 pi by 3 we have taken outside, 2 pi by 3. Only n is remaining. So this n is replaced by 3k plus minus 1. So now if we again simplify it, 2 cos, this 3 will cancel, and 2 pi k plus minus 2 pi upon 3. So this is the value of z. Now, what is the value of 2k pi plus theta? Cos of 2k pi plus theta is nothing but cos 2 pi by 3. And now we know that what is cos 2 pi by 3? It is minus 1 by 2. So 2 into minus 1 by 2, which is equal to minus 1. Therefore, minus 1 plus I root 3 to the upon 2 whole to the power n plus minus 1 minus I root 3 upon 2 whole to the power n is minus 1 for n equal to 3k plus minus 1. So this is our first result. Now, what will happen if the case number 2, if the the value of n is equal to 3k, then theta equal to 2 cos 2n pi upon 3. Suppose n equal to 3k, what will happen? So 2 cos 2 pi upon 3, and this n equal to 3k. So this 3 will cancel, and we have 2 cos 2k pi. But we know that 2k pi, cos of 2k pi is always 1, because if you put k equal to 0, it is 2 pi, 0. If you put k equal to 1, 2 pi, 4 pi, 6 pi, 8 pi. For all these angles, the value of cosine is 1. So we are getting delta is equal to 2. So therefore, the value of this minus I plus I root 3 upon 2 whole to the power n plus minus I root 3 upon 2 whole to the power n, which is equal to 2 for n equal to 3k. So that is, this expression has two values. Its value is minus 1 if n equal to 3k plus minus 1, or its value is 2 if n equal to 3k. Hence proved. This is our result. Thank you.